Idaho's presentation loaded. Why don't you come on down and we'll get that one loaded up.
The focus of this conference has been quality, right? Pavement preservation quality. And I've taken a little different look at this. And what I'm going to show you today is our framework, a methodology for instilling quality in our organizations. And if we can become quality-centric, whether we're a pavement management engineer or we're an asset management engineer, whoever, even in our own lives, if we focus on quality and we understand the aspects and relationships that drive quality, then we're going to produce a better product. Again, I'm Jim Poorbaugh, and currently I'm the asset management engineer for the Idaho Transportation Department. We've had an asset management department for about 2 years, and we're currently transitioning from being a pavement design engineer title to an asset management engineering. So without any further ado, I'm going to give you a quick summary of what our pavement system looks like on our network, and then we'll dive into the framework that we're working to implement throughout our organization. Idaho is a very beautiful state. It's wonderful. I moved there from New Mexico about 5 years ago, and I call it a big little state. That we're the 14th largest state, but yet we have the 7th least population density in the Union. We manage, ITD does about 12,000 lane miles, and one of the unique features is we have 100 miles of unpaved state highways on the system. So there's quality, and we like to talk about quality, but it looks pretty lonely up there. And a lot of people, you know, you've got that old saying, quality's hard to define, but I know it when I see it. And it is kind of obtuse. But we have to add some stuff to that if we want to focus on quality. And what we found is quality, you can't inspect quality, right? We all know this, that you can't. It has to, quality comes from the culture. It has to be woven through the culture. It's a common thread that everybody believes in and gets behind. You also have to have boundaries within your organization, those things that we're going to focus on. And Director Ness, when he arrived many years ago, put forth these 6 key success factors for our organization as we began our journey to become the best transportation department in the nation. And if we understand these are the things that we're going to focus on, and every task that we do drives one of these success measures and has to relate to it. And if it doesn't, then it's probably advisable that you're not working on it. My past history, I ran a project management office for a fairly large civil engineering firm. And many of you have probably seen a triangle similar to this, that project management, the scope, schedule, budget, right? Show of hands, everybody's seen this, right? Well, we've adapted that. And in business, we can talk about people, process, and technology. And every one of us have to deal with those 3 aspects in our organization. And if the relationships between people, process, and technology aren't maintained, it's the same as project management. You're going to have a failure. But again, everything's revolving around quality. I know we're all engineers in here, or technicians, and this is the touchy-feely part, so just stay with me about people, right? Because we're all engineers. We have great personalities and people skills. But one of the things we have to focus on as we move towards quality in our organization and as we implement this framework and process is you can't just jump in and solve the problem. That's what we do, right? Instead, focus on these 3 R's. Relationship. Go out and talk to people. I know it's tough, but get out of that shell, get out of your cube, your office, and go talk to somebody. Because if I can understand them and they understand me and I build that relationship, that's foundational to trust. And I'm asking them to change how they do their job, how they manage their pavement. I'm asking them to change everything that they know. They have to trust me and I have to trust them. Then I'm going to talk about relevance. Why what I do as an asset manager, why is that important to you? And why what you do, the lowliest maintenance guy out there sealing a crack, that's important to me. And I've told them that, and they're amazed. You care that I'm sealing cracks? And I'm like, yes, please, hurry up, do more. Because you're gaining me time, and no one's ever talked about that. So now I've got a trusting relationship. I've developed relevance and understanding between people in the organization. Then we can talk about rigor. How much work am I actually going to do? So I may not need to write that 115-page revised paving spec. I might need a 5-minute email and a 10-minute meeting because we understand each other. And I don't have to overcome all that minutia of misunderstanding and us versus them because I sought the relationship first. Process. Somebody the other day was talking about organizational memory. And, you know, we hear this all the time, like 30 years ago we did a chip seal and a rock broke the governor's windshield, and oh my God, we're never going to do that again. And we cut our nose off to spite our face. We have to focus on the process. If you focus on the outcome, you're never going to have good processes. One thing we focus on at ITD is we've implemented, as far as safety and accidents, we don't blame the operators anymore. What we do is we say, what was the process, what led up to that event? Processes are easy to change, people are not. So we always put the person above the process. Technology, tech is great, I love it. I operate some high-tech vehicles, I love it, I love my smartphone. But it's funny, we have all this technology to communicate with and we're more disconnected than ever. You know, when's the last time you sat down with your family and somebody didn't have their phone going? Or you went out to lunch with a friend and they didn't take a phone call? We have to learn boundaries for technology, and in our practice as asset management engineers or pavement management engineers, what that means is utilize the technology to pull in that data and then transform it to information, and then leverage technology, GIS or SQL reports or whatever you have, to communicate that outwards to your stakeholders. And this is a real struggle for a lot of organizations because it's big bucks, it's time, and it's definitely a skill set that's well sought out. We also have to understand these relationships. And we've talked about training programs and whatnot, but if you understand the relationships, and these are very quantifiable and measurable, the relationship between technology and people is training. So if you don't have a good training program, how do you expect people to exploit your technology, right? And people and process, it's documentation. That's why we all just went through this great process of writing a TAMP. Get your processes in place so people can follow them and they understand what the heck it is that we're trying to achieve as an organization other than just sitting here and getting a paycheck every second Friday. We have to understand the relationship between technology and process, and they have to be compatible. And a lot of us have very advanced technology we're trying to implement for road maintenance and these things, and yet we have these clunky processes that Bob Sill's married to from 1970 when he was first hired. So technology has to relate to process. If it doesn't, you're not going to get quality. This really isn't a triangle, it's a pyramid. And quality is at the pinnacle of that, the vertex of that pyramid. So you have to have talented people if you want quality. You have to have effective processes if you want to drive quality. And on your technology, you have to govern your technology. What is allowed to come into the organization? How do we use it? And if you aren't doing those 6 aspects, you're probably not going to be achieving quality. You're probably not going to be having a lot of fun as an asset management engineer. So how does this tie to how we bring projects forth? And I've had this argument that as a DOT, we don't do projects. We build products. And I always hated it when the people would say, we don't build widgets. And I'm like, we do build widgets. They're roads, they're bridges, they're culverts. And so we build a product, and we produce a product for the stakeholders, which are our taxpayers in our state. Therefore, our products have to follow a product life cycle. And this product life cycle is applicable to Kleenex, to smartphones, to eyeglasses, to shoes. Any product that you have experiences this life cycle. And by that, what it means is that we go through an evaluation phase. So we understand how is my current product doing. Then I plan a new project based on that evaluation. Then I'll design it or develop it. Then I go out and I build the new product and I sell it or I put it into the operational phase. Our roads do the same thing. And as pavement engineers and asset management engineers, you touch every aspect of this product life cycle. And if you can sell this, your stock in the organization is going to go through the roof because you're valuable. You impact every aspect of your organization. And I think a lot of us have been underappreciated and not realized this, and you get pounded back into a hole. But no more. Understand that what you do is relevant to your organization, and that you can define your own goals and how we manage our products. And very quickly, I'm just going to show you that how I walk through this process in my life. I am very fortunate that we own and operate my own data collection vehicles. I have a Pathway Services profiler van. We collect our network of both directions every year, and we do our own data reduction, processing, and reporting. I own a pavement friction tester. We test half the state every other year, and just to keep it simple, we do the odd districts in even years and the even districts in odd years, but whatever. And then I own a FWD, so we go out and test our pavement, and that's by request. We do about 20 to 30 tests a year. Going forward on the evaluation phase, we just joined a pooled fund study for it's $660,000 to get travel speed deflectometer done throughout our district. And we're hoping to utilize that now if we understand the sub-base of our material, of our roadway and its performance, that we're going to be able to optimize the project selection and stretch those dollars even more. Planning, we use Agile Assets. We've got their maintenance module, their fleet module, and then the pavement management module. And that generates our project list. We've leveraged GIS. We have a tool called iPlan that has a lot of roadway data that designers can get to. We do put limitations on projects based on the truck volumes that are seen on the roads, and this really is an austerity measure. And I've talked a lot about relationships, and relationships lead to efficiency and planning. In one district, there was a gal in a meeting. We started talking about what I do. She found out she was the district engineer, planner person, the guru who kept the place running. And she was complaining it took 6 weeks for her to do project planning. I said, well, hey, I got this list I generate every year from TAMS. Why don't you look at it with me? And we went from 4 to 6 weeks of project planning to 4 hours. And we did a 5-year plan for her district. And it was amazing because all of a sudden, again, we're relevant, we're relational, and we found great quality projects. She's getting her pavements on a life cycle. It was amazing. Design, again, it's hard. You don't want to get too, it's difficult because we don't want to micromanage people. One of the aspects we've done when we do project selection, our asset management forecast, we used to have 30 different treatment types we recommended. And then we were always arguing about it, that no, it's not a mill 4, put back 4, or put back 3. It was always this argument. So we've reduced that down to 10 items. And then it's the district to decide with specificity what the treatment is. So again, we heard them as we talked to them, and we've modified our approach for how we specify treatments. Construction, one of the things we're doing is implementing time zero testing, because projects get constructed and then it's a year, we'll get out and maybe look at it. And why that's important is if we can get out there right as construction is completed, we can go perform a falling weight deflectometer test or skid testing and make sure we got what we expected. We can compute a remaining service life, and right there we're going to know if we're going to have problems or we got what we paid for. And again, it's kind of back checking the inspectors as they went through. As far as operations, my son loves to go to his teacher and tell the teacher that dad does crack at work. Yeah, I don't think it's very funny. But anyways, we've started running a crack report. I've got $1 million vehicle that can detect a crack the width of a human hair and tell you how deep it is at 60 miles an hour. So we've got into that database and we report every crack in the district. And from that, I can predict how much volume of sealant you're going to need. And then I can better estimate a maintenance budget and go out there and tell the maintenance guys, I really need you to seal these cracks, and this is where they are. So now you don't have an excuse because guess what? Somebody's watching. And if you do that, we give them credit that on their career path. They have to get points to get promoted. So as they're doing this, they now understand what the impact is. They're not just out wasting time filling cracks. I'm saving that road. I'm adding 5 years of life to that road. And they all know it. It's awesome. And again, Mike Sante's here with me. And he's our pavement engineer, and we're creating feedback loops. So as I do my assessment every year and my evaluations, if I'm seeing things that aren't performing to where we think they should perform based on our performance curves, hey, Mike, we got a problem. Go do some forensics on this thing. What happened? Because you know what? We want less of the bad pavement and those things that are performing above spec. Mike, what did we do here? Because guess what? I want more of that. I want that foreman on every job. Get his brother. So again, we can leverage that technology to improve our processes, and that's going to drive more quality product. Key takeaways. Again, seek the relationship before the result. okay? I know that's hard for engineers, but try it, you'll like it. It'll be tough the first couple of times. You have to ensure that it's a we, not me, okay? It's us. We are all on this journey together. It's not Jim Poorbaugh trying to advance his career. It's me being part of a team building us up so that we build our reputation across the state to our stakeholders, that they're getting value for the tax dollars that are taken away every year from them. Establish a common lexicon. When I say pavement preservation, this is what I mean, okay? And so that common vocabulary, a lot of us, you've got these people that you're talking to them and they're thinking one thing, you're thinking another thing, and then you get 3 weeks down the road and you're like, how did that happen? It's because you didn't have a lexicon. Alignment, alignment, alignment. Understand quality. Understand what everyone does, and everybody has to be on the same page. If you got some stray people going back and forth, you need to bring back and understand why are you not aligning with us. And what you might find is you may need to align with them, and there's a reason. But if you just get angry and you go, Bob and Sally, every time they don't do it the way we've asked them to, there's a reason. Go talk to them and figure it out. And the number one thing I love to say is data is a new currency. Data/information is a new currency. When people would ask me, why do you give me these reports and they ignore me? I'm like, if you can figure out how to leverage this information, you're going to be able to get your projects selected. And all of a sudden, I have all these DEs calling me all the time, asking me, hey, can you run me a report that shows me road X, Y, and Z? Because I want to go to legislature and ask for more money. I'm like, awesome, I can do it. So understand that data is your new currency. And the number one takeaway is you can't solve a problem using the thinking that created that problem. Get outside the box. You don't have to do it the way you've always done it. So with that, I'll kind of stand for questions that probably went a little long in discussion if you have that.
Justin, Oregon DOT. So you mentioned the rolling deflectometer. You're doing that for one district. Is that just for one district, or are you doing that on a selection of pavements statewide? And if you could just tell your thoughts on that a little more.
We actually have experience with the TSD, travel speed deflectometer, and we did a district, we did about 1,000 miles, it's about 3 to 4 years ago. One of our districts wanted to explore this technology, and wildly successful. And the problem here is that the pavement showed generally about 75% of their pavement had less than 10 years service life remaining. Most of it had 5 years or less service life remaining, calculated by the travel speed deflectometer. Because we do visual survey in the van, the district engineer is graded on how much, what their pavement performance is. So the pavement performance showed that his pavements are 92% good or fair. And then I'm doing travel speed deflectometer saying, dude, in 5 years, you're gonna have pavement Armageddon on your hand. And so there's this disconnect. So that's the risk of using travel speed deflectometer. As we go forward, we're planning to collect about 3,000 miles of our 5,200 road miles. It will be across the state, and we're focusing on corridor, because I think one thing that I have found complicated is that we plan projects at the district level. And what we need to do is plan our corridors. And so I'm hoping to use the travel speed deflectometer to say, this is our, we have one corridor, it's almost 600 miles long. It runs from Utah to Canada. And say, this is where we need to invest. Let's prioritize the projects within this corridor. And then if we get that corridor healthy, we can divert funds, get it on a proper life cycle. We can start exploring other options. And that's going to be our tack on moving towards more of preventative maintenance instead of reconstruction.
This is Samaya Nasiri from Washington State University. You mentioned something like measuring the depth of a low severity crack at 60 miles per hour. Would you care to elaborate? I can't stop thinking about it. That sounds amazing.
It's, if Pathways is here, so just jump across the hall. You're looking for Everett Schmidt. He's like a brain, and he'll explain it to you. But what we do is we go down the road, and it's amazing what we do. So that vehicle was almost $1 million, but every second we collect 1,500 data points. So there's a three-dimensional camera on the back, and it shoots pictures of the pavement. And then there's a ultraviolet laser, too, on the back that shoot a beam 14 feet across the road. And so the camera and that laser are aligned. And so the camera takes a picture of the pavement, the laser measures those 1,500 points, and then we come back and we run it through the computer. And all of those points are aligned with the pixels that were taken at that moment in time. And it takes a long time to do that. And then we run that through the computer, and the computer is looking and saying, oh, here's some pixels, and they'll be in cross-section. And so you'll see a line, and then you'll see a dip. And then it'll go back up. And what it does is then longitudinally will connect that, and then it actually will fill that in with a line and says, here's a crack. We run it through another algorithm that we've developed, and it says this is the kind of crack it is. So it's transverse longitudinal, we'll do alligator cracking. So it's very sophisticated technology, and it's amazing. And in a way, it's almost too much data. But again, Pathways is over there. Frugro does the same thing. But the tech is absolutely amazing. It's a fun aspect of it is the district engineers will tell me, you can't possibly know my district better than I do. And I said, can you tell me where all the cracks are in your network off the top of your head? And they can't do it. I'm like, I can. So it's cool. It's very cool. A side note, if you would like to go see what we produce, you can go to PathWeb Idaho. Just Google PathWeb Idaho, and you have to do it from a computer, a Windows computer, and you can see the data that we produce, and that's available to anyone around the world to look at, and we've pulled that up in board meetings and showed people. So you'll get a cross-section of the road, and it'll show you our IRI and profile of the road. And then internally, we kind of have the grown-up version of that, where we can actually do the correct classification and counting.
Maybe you said this earlier. Are you guys manually rating your roads, or using the auto function?
So the first year I had this job, yes, we have always done visual windshield surveys. And my first year in this job, I spent a very long time in cars traveling every road in Idaho. And I got to tell you, my tail feather was killing me at the end of it. And it's absolutely, totally ineffective. We had an iPad, and I'm rating the roads, and some of those roads were whipping along, and they're 12% grade and 25 miles an hour and curves everywhere, and I was, half the day was pull over, I'm going to throw up. It was so ineffective, and I'm going, my God, I got $1 million van, and it's doing all this, and I'm like, why am I out on the road? And you know, the old lady's mad at me, the kids don't know who I am, and I'm coming home and the dog's barking at me because I'm gone all the time looking at roads. And so I said, why are we doing this visual survey? And you know what the answer was? It's how we've always done it. And I was like, I'm not doing it anymore. You either let me use the van, and I can sit and we can scan it and look for areas of distress, and then places I can identify, go to the districts, and then if we want to argue about, hey, your van was stupid, it didn't get the right answer, I'll drive out to very specific locations and talk to you, and we can noodle on it and come to an agreement, because either you're wrong or my model was wrong. Again, relevance. Then we can either I adjust my model or you need to adjust your way of thinking because my model was correct. But we don't go out and visually inspect roads for the whole network anymore. I have some technicians that sit and do quality assurance on the cracks, just driving the road, sitting at their desk, and we do a little bit every day over the course of several months, and that's what we do. But no more driving around doing windshield surveys. Total waste of time. Right. I learned more about some of these folks. It was great quality time bonding with a lot of the materials engineers. But I learned more about their personal lives and their background than I did about the pavements.
I guess I should have been clear. It wasn't really about windshield surveys, but you have people behind monitors doing quality checks on the automated crack collection.
We will do quality assurance on about 10% of our network. So we pick just randomly 1,200 about 1,200 miles, and we'll scan that, and then they go back through and make sure that the scoring is correct, and we agree, and the software will let us reclassify cracks if they're wrong. So we actually discovered it couldn't discern between block cracking and transverse cracking was one of the things. So we went back and said we won't detect block cracking, we'll just call it a transverse crack. It had great difficulty discerning between those two. So yes, we do validate and do quality assurance, quality control.
What's the size of the hard drive, storage unit, or whatever you use, and what's the speed of your processing unit to be able to handle that volume of data?
We generate about 15 terabytes of data a year. We can do this we have solid state drives, and each one's a terabyte. When we operate the van, there's 6 drives that are running continuously to collect data. But at the end of the day, when we process it, we run somewhere 12 to 15 terabytes of data. Our servers for this run $25,000 a piece, and there are 8 4-core processors in each system. We're currently working to try to, the current time frame for processing is it's about 1 day of collection for 1 day of processing. Very labor intensive. And so we're currently trying to working with the vendor to devise a virtual server, because each data packet that we collect goes to its own processor. So in that case, if I have 8 4-core processors, I can do 32 packets at once. And what we're trying to do is create a virtual server. I can have an infinite number of processors. And so if I could go to 128 processors in a virtual server, I can quadruple my throughput. Well, that sounds really easy. It's kind of like talking to a car mechanic when you talk to an IT guy. So there's some problems with that, and I'm like, dude, just fix it. And they're like, we're working on it. How much money you got? So, so it's about a day for it. It's about a day for a day. And again, it's really just a standard processors. There's just a lot of them to run the analysis and assessment. Okay, if that's it, thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.